Okay, this one is for Wednesday's class to go over the different disorders and diseases that were covered. Um, it's pretty early in the morning here, so half whispering. I hope you can hear me well enough. Um, anyhow, I'm going to go through them, I guess, in the order that you guys talked about them in class. So this is the exact file that's on the blog. You can look at it any time and print it off. Okay, so um, the first disorders that you actually heard about would have been albinism. Okay, so Emily and Sherry did this one. As role plays, they were Emma, and they had a cousin named Liam who had this genetic condition. Basically, they're lacking one of the enzymes that's required, or a way of getting the enzyme into the cells that makes pigment. So um, the symptoms are the person appears to have very little coloring in them at all. They have white hair, very, very fair skin, very, very white, and either light blue or pink eyes, reddish eyes. It's autosomal recessive, and we did a few activities, lab-based activities with this condition. So if if both parents are carriers of the allele, then they have a chance of giving their child albinism. Um, let's see. The next one that was done was Tay-Sachs disease. So Kyle and Kelsey did this one, and their role play, they were Pat, and they just found out that their 1-year-old named Sophie had this fatal genetic disease. So Tay-Sachs, if you look, Tay-Sachs results in buildup of fatty stuff that causes brain cells to die. Um, Basically, they're lacking an enzyme that helps to break down the certain lipids or fats normally, and because they're not being broken down, they build up and they destroy the brain cells that they're in. Usually the onset or the symptoms will start showing around 8 months or so when their brains and spinal cords start to deteriorate. It's a very fairly quick um, progressing. They're often blind and mentally disabled by the time they're a year old, and most die by the time they're age 5. This one's also autosomal recessive, so it would be passed on in a similar fashion to albinism. Okay, so for some, if they know that a condition like this passes on um, in their family history, then they may want to have um, genetic testing done before they have children, just so they know their chances of passing on something like this. Okay, so that was Thursdays. On Friday, we had Aaron, and I guess I did the one in the morning class. So this was Heidi. And Heidi has a friend named Helena at university. And Helena is, she was African American. This tends to be more common in African American background, but it can be passed on to other cultures as well. It's sickle cell anemia, and basically she had a defect in her hemoglobin, which causes her red blood cells to be sickle shaped. You can see in this picture here. Okay, let me see if I can find my pen. Okay, so there's the sickle shaped one. A sickle is a It's an old tool that they used to use for gardening and for um, gathering of crops when they did it by hand. So because of its strange shape, it tends to lead to a lot of blood clots and reduced flow to organs, so it increases their chances of stroke. It's very painful. They have weak muscle tone, little energy because the oxygen isn't going to get to the tissues as well. Poor immune system, constant pain. There's actually a video if you wanted to show it if there's time in class today. There's a video in the lessons folder that can be watched about this particular disorder. Type of inheritance, it's codominant. So like we said in class, if the person has both of the S alleles, then they would have the disease. If they have the A and S alleles, then they have a heterozygous advantage. That means that they have um, a positive characteristic. They don't have the disease, but it leads to them having um, kind of a resistance to developing malaria, which is a common illness in Africa. So if they happen to have both types of dominant alleles, then that gives them an advantage over others in fighting malaria. Okay, that was Fridays. On Monday, Monday, um, Monday's class in the morning, both of these were done by video. In the afternoon, we had Caitlin, and oops, I want this one. So, first person in video in the morning, and Caitlin in the afternoon. Um, they were named Summer, and Summer was doing respite care for a family um, who had a boy named Tommy. And Tommy has a genetic condition in which there were duplications. So this is due to a mutation. Okay, so mutations in the chromosome. It's the X chromosome. So they have duplication. So instead of normal 29 repeats of this particular gene on the X chromosome, they have like 700 or so, which makes that X chromosome fragile. Okay, it's easy for it to be distorted or broken, and the symptoms they show are a long face. If you look at the pictures to the side, they have a long face, their ears are protruding, they tend to have mental disabilities, be autistic, of a wide spectrum, stereotypical movements, atypical social behaviors, and they're female, they don't tend to show quite as severe symptoms because they have that other X chromosome to kind of compensate. Okay, that was the first one on Monday. Second one on Monday was Shauna for the video. And this person's name is Felicity. She has an 8-month-old, and she was showing pictures of this other child who has the same condition as her daughter. It's caused by a mutation. So in this case, the mutation is deletion of part of chromosome 5. And while they have similar features to um, children who have Fragile X, these ones tend to have a, the the real key characteristic is um, the real key characteristic is an abnormal larynx. So when they cry, they sound like a cat, and their facial appearance is also very characteristic, where they tend to have a large overbite. Um, they have problems in learning, problems in understanding, speaking properly, things like that. So, but the key thing is the abnormal larynx, which makes them sound like a mewing cat when they cry. Okay, so Shauna, or the one in the video, whose name was Felicity, that disorder was Cri du chat, or cry of the cat. Okay, Tuesday, let's see, we had Bev in the morning and Brittany in the afternoon, and their name for their role play was Kate. Let's see, Kate had a boyfriend named Todd, and she was talking a little bit about his condition. And his condition was, oh, where is it? Red-green color blindness. Okay, so this one is caused by a defective allele for pigment that's responsible for detecting red or green colors. They can't distinguish between red and green, so because they can't, they have to have special drivers test where they recognize shapes instead for the lights because they can't tell when it's red or green. There's a lot of other issues that come up for them. They have difficulty in recognizing colors that go together, anything like that, because they can't tell what's red or green. Um, right now, they wouldn't be able to. They see shades of gray probably for the cause, symptoms, and type of inheritance that are on the page. Okay, it's an X-linked recessive disorder, so if you were figuring out Punnett squares with this one, you'd have to use your X and Y chromosomes with the alleles on the X only. Okay, so this one tends to be more common in men. If you can't see the number amongst the green dots, then that's one way of testing to see if you have red-green color blindness. Okay, so you should be able to see an 8. If you can't, then there's a possibility that you might have red-green color blindness. The other one on Friday was I did it in the morning class, and Haley did it in the afternoon class. And it is the rapid aging disease. So it's caused by a spontaneous mutation of a particular gene. It causes the child to age really, really rapidly. So they show signs of old age very early on. You got to see the video of the young girl. She was in the morning class. She was 14 years old in the video. In the afternoon class, it spoke of her after she died when she was 18, so she lived longer than most, as most only tend to live till they're 13 at the most. So signs that they would see are similar to the ones that you see of people of old age. They lose their hair, they lose their teeth, they have weakened bodies, their organs start to deteriorate and shut down early. Um, it is a dominant disorder, so if they were able to have children, then they would pass it on easily to their children. Obviously, it's caused by a spontaneous mutation because for them to get it from a parent, then the parent would have had to have it. So rather, it's something that comes up spontaneously. It's not passed on from the parent. If they were able to have children in their short lifetime, then they would pass it on to their children. Okay. That's funny. I think I have them mixed up. Anyway, my days are mixed up. I did Friday after Tuesday. Anyhow, we'll get through them all. The other one that was done Tuesday was by Katie. And Katie did hemophilia. Let me see. Where did I put that one? Nope. Near the end. Okay. Katie was Katie was Kent, and I was Kent on the video. So he had a genetic disorder that can be life-threatening. It's also another X-linked, so it's linked to the X chromosome. So if you were doing um, a Punnett square with this one, you'd have to use your X and Y and put the alleles as superscripts, right? It tends to be more common in men, and basically, it's a blood problem. They lack blood clotting factors, so because their blood doesn't clot, a simple cut or bruise could cause them to actually die if they're not treated effectively and quickly with certain medications. Okay, sorry for the confusion. I guess I forgot one of the Fridays in there. Um, I'm hoping that Jenna Lee had a chance to do hers as well. Jenna Lee was a mom who just had her baby, and like any mom now that has their babies are automatically tested to see if they have PKU, which stands for phenylketonuria. Basically, with this condition, um, the babies appear normal at birth, but if they're not diagnosed and treated, which is really only having to put them on a special diet, then they could develop severe mental disabilities within months. That's why they're routinely tested. It's a very quick test. Basically, it's an autosomal recessive disorder. It causes a lack of a particular enzyme that normally converts phenylalanine to tyrosine. And because that's not there, then the products um, from the abnormal breakdown can cause damage to the nervous system. Okay, so it's routinely checked for now, and it's easily treated with diet. So let's see, have we covered them all? We did Fragile X, we did Cri du Chat, we did Tay-Sachs, PKU, albinism, sickle cell anemia, progeria, Huntington's. Now, Huntington's, I didn't get anyone to do a role play because we've done a role play before on this one, but we didn't look at it from the genetics side. Okay, so if you remember, Huntington's is the one that usually has an onset um, around the age 35. Basically, it's an autosomal dominant. So because it's autosomal dominant, then if a parent is a carrier of the dominant gene, then they have a 50-50 chance of passing it on to their children. So I think I told you at the time about one of my past ministers, and he got tested genetically, and he knew that he had this allele and that he will develop the symptoms of the disease himself. But because he knew that he had a 50-50 chance of passing it on to his children, he and his wife chose to adopt instead. Um, it Once it starts to develop and progress, it eventually will cause them to lose motor function, their memory, their ability to speak. Most tend to die in their 40s or 50s. So it's not as quick as something like ALS, but it is a fatal genetic disorder. So that's Huntington's. And I think the last one, we've done red-green color blindness and hemophilia. So the last one is hypercholesteremia. And if you look at the words, hyper means more than normal. Cholesteremia, okay, think cholesterol, and emia has to do with your blood. So you have more than the normal amount of cholesterol in your blood. Okay, this one is incomplete dominance. That's the type of inheritance. Okay, so they tend to have a defective allele for the gene that codes for LDL receptors on the surface of cells. These are the receptors that the low density cholesterol molecules must bind to in order to be taken up. So since it's defective, then more of the cholesterol is left out in the blood. Okay, so symptoms would be higher than normal blood cholesterol levels if they're heterozygous, and they'd have half the number of receptors, so about twice as much blood cholesterol. If they're homozygous recessive, then they have no receptors. So if they're homozygous recessive, then they have like a lot of cholesterol in their blood. Okay, so they'd end up with higher blood pressure than most, likelier chance of having heart disease, etc., etc. Okay, so if they are, so when we say incomplete dominance, it means that um, if they had the dominant allele, so if, let's say they had homozygous, let's say the letters were big C, big C, they had big C, then um, we'll do, never mind. Anyway, if they have both of the regular dominant alleles, then they'd have normal cholesterol. If they have one of each, so let's say it was big C and big D, if they're heterozygous, then they would have in between the dominant and the recessive. And if they had, I should have used a prime, the letters aren't great here, but if they had both recessive, then they'd have really high cholesterol. So the heterozygous is in between. It's not, you don't still show the dominant trait, you show the in between. That's what they mean by incomplete dominance. Okay, so that's it for the disorders. Again, if you have any questions, I'm going to try and hopefully have access to internet while I'm in, and I'll let you know. Please check the blog. I'll try and update there if I get my internet access on Monday. I'll put a little post up, and hopefully you've had a chance to see the little video on Charlie, and I'll try and keep you updated on how he's doing. Today should be Wednesday's class, so you may be spending the rest of the class doing your bio rhymes, or you may be working on study tools. Depends on how much time was needed for the different videos for the lessons. Thursday's class, hopefully I'll have a game prepared for you to review with. But please, if you do have questions, send me an email or text me to let me know that you have a question, and I'll try and find a way of being able to answer. Good luck, and been thinking about you all.